In this session, what we'll be going through is config map, a secret, so deployment. Config map, it is nothing but any environment variables or any application, right? If it requires some kind of a configuration, a database URL. If I type config map here, I will be getting a config map related details. How exactly config map has to be created? I can take this particular data. I'll create a file called as a cm.yaml. So now I'll copy the same thing. API version, type of a v1, kind. Here if you it's a config. Any Kubernetes resources, this top parameter will be same. Okay, meaning this key and value. Okay, this key remains the same. The value can change. Okay, in this case, I am creating a Kubernetes config map. Right? So that is the reason kind is config map. So metadata name this keys means the same all across any Kubernetes resource. So here in the data field, what I'm giving is a key variable I'm giving it, configuration, their initialize equals 3. That is the value I'm putting it. UI property file, the key, this is the value I'm giving it. This is a self-defined config map. Okay, whatever you wanted as part of your application, right? That is what you are giving it to. Create this config map in Kubernetes. How exactly you do it? You will run kubectl apply -f and then that YAML file. -f stand for a file. Enter that. Will say config map demo has been created. In this way, we try to create a config map. In order to check the existing config map present in the Kubernetes, the command what you use is kubectl tm. Okay, I will say config map. I have config map is present in my Minikube cluster. So you can say like this config map, a bigger name. There is a shorter name is also available. You can say simply CM. CM stands for a config map. You'll be able to see the same data. If you wanted to view it, the command is describe CM. kubectl is a command. This is the verb, what exactly you wanted to do. But next one is a resource name. In this case, it is a config map, or it can be if you wanted to check the secret or pod description, can do that. So in this case, I wanted to describe my config map, existing config map. This config map has these data. Delete the existing config map. I will say kubectl delete tm is for a config map and the config map name. In the config map, db-config is deleted. What is Kubernetes? So in our application, obviously we will be having some secrets, right? Username and password of a database or some access token, which has to be accessed only by the pod. You can't keep the secrets inside our repo. Otherwise, if someone has access to Git repo, you would be able to see it in the naked eye and can hack into your system. So in order to keep our application safe and secure, so all the username and password tokens or a key, so those are the things we keep in a Kubernetes secret. The secret is not hard coded into the application code itself, or it is not kept it in a config map or inside the repo. So let us go back to our Kubernetes.io. Let us search secret. The first one you selected is a secret example. Let us go and the name of the file can be anything. Here if you could see, this is a base64 encoding we need to do. So let us go to the creation of it. So we have created the YAML file here. If you wanted to create this, you will run simply kubectl apply -f and the secret.yaml. If you see dot file, it has been created. If I do a get secret and see file secret has been is there. Here if you could see, this is a base64 encoding we need to do. Echo to decode the string. Decode in pipe symbols base64 -d. -d stands for a decode. Okay. You enter encoded value. The actual plain text is value -2. It has been encoded and in this format it is there. Go back to here. So let us add few variables. So I wanted to add username, password. Wanted to introduce this particular secret, highly secretive array to has generated like this. Let us save this particular file. The name and password. So I wanted to see it. How you can do it? You do D. This is test user. This is what it has been kept it in this particular set. You wanted to delete it. Okay. So first what you need to do, get it. So which are all the things you wanted to delete it? Secret name. If you enter it, has been deleted. In Kubernetes deployment, the parent of our pod. Our deployment is it's a high level abstraction of our pod. Here if you could see in the template section, so if you are creating any pod, we will be having only these section containers and the image, the container pod. So if you wanted to create, if you have created only a pod, right? If something happens and it gets deleted, one of your colleague has deleted it, then automatically this particular pod won't be recreated. You create a deployment, right? What it does is it will make sure that if someone accidentally deletes also, automatically Kubernetes will make sure your deployment is auto-created. Self-healing concept will come into picture. Automatically, someone deletes it, will go and recreate it. You can mention how many replicas it is. Let us understand how exactly the pod works. So think that now, particular demo application, okay, due to some reason, okay, someone deleted it. If someone deletes it, no way you can bring it back unless you run will apply again. That will only it will bring it up. If you wanted a 10 copies of the same demo application, you can't do it. You have to give a different name and scale it up to 10. Okay, 10 times you need to run with the different names. It is not a good way to scale your application. Let us go to our deployment. So once you search over here, click on the deployment. So what we do is the same kind of a application what we had now. Right, copy this, but will create the name of the file can be anything. So if you see here, top 4 is the same thing. Only difference is the kind is what type of a Kubernetes is. Yes, it's a deployment. Here we are saying the replicas equals 3. So it should create a 3 pods. Okay, so in the safer side, let us make it as a 1. The name of a container, it's the same version of Nginx. Okay, rest other details, whatever we had our pod, right? This is the same pod details. Okay, that is what it has been mentioned over here. But it is wrapped around the deployment. So now if I say get pod, right, of the resource present, so I wanted to create my deployment. I will run this. So it says deployment has been created. So if I go for a hierarchy, right, deployment name is next deployment. So next bit is a replica set. You can call it as a replica set. So if you could see, this is the name of our deployment. That is what it has been appended over here. This is a random generated number. So if you say get pods here, same thing, it has been copied over here. And for the pod, extra bit has been appended. Hierarchy wise, pod is at the bottom. So that one is a replica set, which makes sure that how many pods it has to be run. On top of that one, we have a Nginx deploy. Think that the same example, if we delete it out, delete the pod. So accidentally someone will delete pod. In the pod case, won't create automatically, right? Get pod again, already it has append running. Here one was 82 seconds. Here 6 seconds ago, this pod it has been regenerated. How you can see it? The old pod name was like this. Okay, until this one is a replica set name, okay, which is derived from a deployment name, and this is the extra for a replica set. Okay, this is the unique number for each pod. The older pod was which we deleted, right? That pod name was this one. Now the new one is like, okay. So in this way, someone accidentally deletes also, right? We should be able to bring it up, and automatically Kubernetes will make sure that it is required is 1. Okay? It has to be recreated. That is the magic of our Kubernetes. Now there is a hell lot of load is there. Okay, so one is unable to withstand. Okay, many guys are seeing a downgraded performance in our application. Okay, now I wanted to increase the replicas to 10, meaning 10 pods I wanted in order to withstand the hell lot of a load. Okay, let's save it. So now what I will do, I have to apply the new configuration. If you see, it has been configured. So now if I go and see get pod, the old one, if you see, it is 113 seconds ago. The rest other bit, it is creating. So if you see, all 10 are back into the action. Okay. Within a one configuration change, it has scaled our same application into 10 pods. Okay. This is the magic of our Kubernetes. Think that now again load was there, load has reduced now. Now I don't want 10, I need only 3. I will save that and again I will run it. It says configured. So now if you say get the pods, right, automatically within a fraction of a second it will keep on deleting unwanted stuff. It keeps only 3 bits. So if you wanted to delete some pod, right, now think that this particular application you don't want to work anymore. Okay? In order to save your cost, memory and all. So you don't want this one. So probably after 1 month you wanted to work on that. Okay? You can't keep this application up and running. Unnecessary memory, space and all. We don't want it. But if you wanted to delete this, what will happen? We'll go and recreate. Kubernetes will, once this deployment will go and recreate. So there are 2 options are there. So what we could do is, we can take a replicas as a 0. So automatically, if you apply it, automatically delete it off all the pods. It picked it up, has deleted everything. In this way, you can do it. Or what you could do is, kubectl can like this. Kubectl is our deployment. You can delete the deployment. There are 2 ways of deleting it. Okay, it and the name of it. Deployment is let us recreate it, and I will show. Like so, the way you apply it, right? Like that same. First, we'll apply it. It the deployment. Obviously, it will create the pods as well. Wanted to delete it. Okay, so what we could do is can say directly delete deployment, or the apply command we have run, right? Instead of apply, just say delete. What it will do is just deleted it. All the pod was existing some 10 seconds ago. Now everything is gone. Okay. Another way of delete. Coming back to our actual use case, let us go and deploy a MySQL database. So in order to create a MySQL database, let us try to use all these stuffs. Okay, that is config maps, secret, and deployment in order to deploy our MySQL database. So now what we have done is, so here for this particular example, what we have done is have created a user as a secret in order to create MySQL database. Right? So we should have our own root password. We need to mention it to MySQL data. Otherwise, someone has to was installing it, right? He should be knowing about. Let us go to this particular location. Coming back to here. So now in this folder, we have all this secrets. Okay, so let us go and create. So this is secret is used for a MySQL database. Okay, so how exactly we put in order to create these secrets? Create like this. Or secret has been created. Check that secret. Or the secret 8 seconds ago it has been created. Now I wanted to create a root secret as well. It was already exists, so that is the reason it said the 6 days ago I could have created. For the deletion, that's another bit. Still 3 seconds, 47. So now if you see, we don't have any pods, okay, in our namespace. Okay. So now we wanted to deploy our MySQL database. We require only the service. We require only the deployment. So if you remember, we had created a config map. So if you could have a config map, here we are mentioning data or database name. Okay, automatically what it will do is create a MySQL database as well. Okay. So how you do it? Normal case, kubectl apply for MySQL and you see for config in create. Once it has been created, then the next step is you wanted to run our deployment. So if you go to our deployment, as usual, have a name called as a MySQL, kind as a deployment, the name as our MySQL. So here what we are doing here, we are mentioning a container name as MySQL.7 version. So we have a MySQL name. Here we are giving a MySQL. If you remember, we have to set our MySQL root password. If you wanted to install any MySQL database, right? Obviously, we have to set the environment variable, root password. Otherwise, container won't start at all. Okay? During the startup or boot time or running time of a MySQL, someone has to enter the root password. Otherwise, it won't install. Okay? That is the reason we set this particular environment variable. Here, what we are saying here is MySQL root password. Okay? This environment variable will be set from a value from a secret key reference. Okay, that is a secret. His name is root password. This is our secret. That is root password. Okay, root password. It has to pick a password value. The key, what it does is inside whatever the password is present, right? Whatever value that will be set as a MySQL password. In our case, let us go and view it. Password, I will say -o-yaml file. -o stands for output. Output format, in the YAML format, output I want. Our root password is this. Root password, the name of the secret is root password. It has a password key and this is the value. Okay. Here if you could see, root secret key reference is secret is root password and the password is the key. So password is this one. Okay. This value, whatever it is there, it will be picked up over here. Okay. And it will be set as a MySQL pass. We could have done like this as well, rather than making it as a simple. The password, if I decouple, okay, decode it. If you see, it's a admin123. We could have done like this as well. Okay, so what it will become is it becomes a hard coding. Can't change it. We are not interested in that. We don't want to do a hard coding because anyone has access to your code base, right? He can decode it, right? They can easily hack into that. That is the reason what we are doing is we are picking the value from our secret key reference. From a secret, whatever in the secret we have kept it, right? That we are assigning it. So obviously we wanted a multiple application user has to be created, a TB user. Similarly, We have created a secret called as a DB user. We have a DB user. Why we create a DB user is, if we have a n number of application, right? We wanted to keep a separate database for each of the application. That is the reason we have created a DB user. For that, username is this, password is this, values we have kept it. So here we are setting a username for our application, okay, over here. Okay. What it does is, it goes to value, it has to get it from username. Value will be set from a secret. Name called as a DB user. That is this one, DB user. Okay. It is picking a username. Okay, username. This value, it will be set for this MySQL user. Okay. Similarly, password is set. Okay. This is on the secret. How exactly for a pod we add or fetch the values from a secret and attach to our pod. The second one is a config map. Okay. Similar concept. The value, the MySQL database, how exactly we are setting a value from whatever here if you see secret key reference, instead of a secret, we have kept the MySQL database in dbconfig, right? So that in a config map. So that is the reason, only difference is this part, config map. It's similar concept, how it the value picks it up. That is what it has been mentioned it for here. The next bit is, this is what, how you configure one application along with our config map as well as a secret. Okay. So now what we will do is, we will go and create this particular MySQL database. So let us, how exactly we run it? Simple, same command. Apply -f and then our database deployment.yaml deployment. So here if you could see, it will create a deployment as well as create a service. A service is to front end our application. Okay. Our MySQL database in this case. So I run this, but if you could see, service was already there. That is the reason it said unchanged. So MySQL is created. So if I go and check my pod, okay, it will latest. I will this container white error which pull was the version earlier was like it deprecated. Let us wait for it. So here when I run it, right? So what it did was, it created a deployment for us called as a MySQL. Because set, if you wanted to see it as a shortcut name is RS MySQL data and our pod. You see, our MySQL pod is up and running, right? So in this way, we create our deployment. MySQL application is running now. It is using secrets and config. The way I have explained it has been added. Now, if you could here, this is what we have been using it. So MySQL database, if you wanted to check it out, how exactly the MySQL database has been created, the command Kubernetes is kubectl exit for execution minus IT stand for a interactive mode, then pod name /bin /bash. I enter. Now I am logged inside the MySQL. Okay. This once itself, it doesn't exist because these are all the containers, right? So you won't be having all the data. So now I wanted to run MySQL -2 boot user and for a password. If I enter this password, I have logged in. Okay, so you wanted to see the database. So in MySQL, you can say show databases. So if you see, our student DB has been created. You wanted to see the database inside that, you can see use database. Use has been changed. They show tables. How many tables present in our database? So it is because it has been freshly created. So let us exit here. Okay. In this way, we create this MySQL database. In tomorrow's session, what we will do is, we try to take up deployment of a Spring Boot application into our Kubernetes. So if you go to kubernetes.io, kubernetes.io is a single source of truth related to Kubernetes. Whatever the changes, it is current changes are there, right? Everything you can find it out over here. Okay? Even if you are doing a certified Kubernetes administrator or a CKAD, so you should be able to open one tab, that is a kubernetes.io tab. That is the reason I would suggest you to always, for any Kubernetes related bit, right, search it over here. You will get all the information. If you like this kind of a video, appreciate if you could add a comment. Catch up tomorrow.